Example number 3, connecting a sinusoidal function to oscillating motion. This right here was on the very first applied exam, this idea of a swinging motion. So I just want us to kind of picture it in our heads. Think about the height of a swing. So let's just read the question before I go into it. So for a physics project, Morgan and Lily had a graph. Had two graphs and analyzed an example of simple harmonic motion. Morgan swung on a swing, and Lily used the motion detector to measure Morgan's height above the ground over time as she swung back and forth. The girls then graphed their data as shown. At the end of each cycle, the swing returned to its initial position, which resulted in a sinusoidal graph. So think about it. What's happening here, it says the first question here is interpret the graph. So I'm going to interpret it in a very physical way, and then we're going to interpret it using the tools that we just learned in the previous lesson and in the previous video. Actually, we're going to talk about the range, the equation of midline, the amplitude, and the period. But first things first, we're starting at a maximum here, so that means that the swing, okay, the swing is first 2 meters off the ground. Then when it swings below 1 meter. So here's my swing, and I'm going to say that this right here is going to be 1 meter. So it dips right below here, and then it hits a maximum again. The maximum being 2 meters. Okay, so this right here is the swing. It moves this way and then moves this way, but then it goes back down to that low point. So then it goes this way, then this way. Okay, and it keeps on rocking back and goes from maximum to maximum, which is 2 meters, and it keeps on going down to its minimum height, which is less than 1 meter. So now that we know this, let's identify a few things. So first things first, let's talk about range. We know that the range goes from 2 meters to about, if this is half a meter, this is 0.75. So we're going to go, and it's just a little bit above 0.75. So what I'll do is I'll say that it's 0.78. It's less than or equal to y, which is less than or equal to, and what I want to do is I just want to write down what label those axes there, just so that it makes sense. Is less than or equal to y, which is less than or equal to positive 2. The next thing, we want to have the equation of midline. And remember, it always has to be expressed as an equation. So it's going to be y equals 1.22 over 2, which is y equals 0.61. So the equation of the midline is, So the equation of the midline is going to be y equals 2 plus 0.78 over 2. I'm going to say y equals 2.78 divided by 2. So then the final equation of the midline is 1.39. Let's now talk about the amplitude. So I'm going to say that it is the maximum, 2, minus the equation of the midline, 1.39, and I'm left with an amplitude of 0.61. And we're noticing that it's in meters. Last but not least, let's talk about the period. So there's a maximum at 1.5, and then there's another maximum at 3. So to find the period, we're going to say 3.0, or just 3, minus the x value of the previous maximum, so 1.5. So the period is 1.5 seconds, because that's what our our x-axis is measured in. So we've done that. So let's see. Determine Morgan's height above the ground at 4 seconds. Literally, what we do is we go to the graph. We hit it right here, and it's going to be at 1 meter.